Hello guys, this is my finished CNC machines, and I finished it almost for 1 year, and during this periods of times I concentrate myself on another project. There's the tool changers that you see here at the back of the machine. This box is 7 tool pockets, tool changers, and in this video or episodes I am not going to talk about the mechanical parts of this. Instead, I will concentrate on the electronics and all some softwares. And here is the 3D models, and I only show part of it. Some parts are hidden, and the two long pieces is the rail, and for this toolbox move forward and backward. And here is the top surface of the toolbox, and I reverse it, and here is 7 hoses for the pockets, and the electronic boards were finished, and I installed the photo sensors on each pocket. Here is this dark color is the receiver, and the transparent one here you can see something like the LED is the emitter, and this is it inserted here. There's a hole inside, and there is hole on the opposite side, and also the emitter installed there, so the light going through. And if there is 2 installed here, it will block the light, and since the 2 already in the pocket, otherwise it will on the spindle holder. The purpose is the preventions, the collision, if the tools were not properly installed or removed from the spindle or the pockets. You can tell the machine. And here, and also there is some installation. This is, I purchased this one. This is the sensor, photo sensors, and if there is some objects in front of it, it will sense. And I installed several pieces on the front of the box, and also several pieces on the top of the box, and just also for the prevention of the collision. And just, you can say it's just for fun. And I now test it. Let me connect the electricity there. It's difficult to handle it. It's a bit difficult. Okay, you climb it on the stand. And there is 3 pinouts, two for the voltage and ground, and one is for the output. It seems respond. Yes. So there is it power on, and if there is some object on the front, another light leads on. It's very simple circuitry, and I will, for the several pieces, I will parallel them and have the same output to the, you can say, the CPU or the Visa card board. So there is totally one output for this photo sensor, and another output is for this photo sensor. These 7 pockets have individual sensor output, have 7 output, and this is only one. They are parallel together. And some notice on this: if they are parallel together, when either one of them are sensed and the output light will turn on, all the other or all the rest also leads on. So it's not quite good. So I need to make some slight modification on this. And here you can see some wire were connected. The purpose is to prevent the little problem. If it was not, if modified, there is also no much bad effect. Anyway, let me check and is the and here is the dual operation amplifier IC, and it only use one of it for the operation, and the output will here one of the pins, and also the output will use to turn on this LED. And I change it. Here is the circuitry. I draw it roughly. Anyway, here is output, and it go to this LED first. But now disconnect this and take this LED out. No, I connect this. You can see this path. Connect it to another operation amplifier, And originally this output, no, actually this output is this operation amplifier here. So for the input of operation amplifier is the photo cell, photo emitter, and receiver. Those input also connect to this unused operation amplifier. So at the same time, these two operation amplifier will have output. One is for the actual output pin, another is for turn on this LED. It's quite simple, and do some wire connection here. So in this ways, there are several circuit board parallel connect. So in this way, the other circuit board have output will not affect this LED, since the output pin already disconnect with it, and this output LED only affected by its IC. So this is quite simple. And now here talk about the other circuitries. And here is, I take this out. I put on the insulation board underneath here, and you can see here and here. And for the photo emitter here, because it's a long narrow pieces, so I divide it into two pieces. And here also there is little pieces here on left and right side. These are used to connect these long pieces circuitry to here. There is connector here as well here. So for the photo cell little circuit board here, I connect to this main large board, and here I connect to this large board, and there is pin and socket here. You can see here. And the LED originally it was this way, and I turn it to right angle, and here is right angle here. And I insert it to this position, and there are a hole on here. And now I mention here, these two large hole is for this LEDs or photo cell, and there is as well there are three holes, small hole here. And I mention here once again, this spot there is a variable resistor here. So when this spot, you can adjust the checking position. It's done by turning this variable resistor to adjust it to check if the object heated at the nearest position of father, you can adjust this variable resistor. And this 3 hole, the center hole is for insert the screwdriver to turn on. So once the box are finished, I can adjust it outside. And the other 2 little holes is for the indication of the LED, and you can see here that, and 1, 2 here, my finger points out, there are 2 LED, and here there are 2 hoses, and you can see it not very clear. I inserted a transparent material there on these 2 small holes for conducting the light from here to outside. And I use this, you can see this, I bring it here, and here is, I cut the transparent rod and insert it to this small hole. And these 2 board, there is empty here. I need to connect them, use these wires. And for the upper side, you can see there are 3 piece sensor board. I connect to these long pieces with connector and socket. The main purpose of these 2 large board, almost none. There's almost no electronic components there. Only some SMP. You can't see it there. It's very small. Only several pieces SMD resistor and 0.1 microfarad capacitor, also SMP component. Here. There is also some SMP resistor there. And beside this board, there is also here is a main board. What is the purpose of it? The output of it will be sent to this main board, and there is IC here. This is only a buffer IC for those output of this photo cell. The signal will be make a clear signal here. Use this buffer IC, and on the other side of this board, you can see here is some MOSFET here. So the function of this main board, let me explain. For these 2 boxes, let me open the file. To to rotate the spindle, the tool holder. This is ER20 tool holder or nut, spindle nut. I need a stronger motor and gearboxes, and you can see here this one. It was hidden inside these cases. Actually, this is a big motor, 770. I don't remember, or 715 series. It should be 770 series DC motor, and also a gearbox. The gearbox is actually I taken out from a drill, rechargeable drill that is my old pieces. I didn't use now. I take the gearbox and clutch, and as well the motor. This is the drill motor and gearbox, and also a gearbox there. So I need to turn this big motor on and off. And also there is, you can see here is another gearbox here. This gearbox is used to move the whole tool changer spot forward and backward. This is a general 500 series, I don't remember, something there, this motor, and it's not big power enough. And in this gearbox you can see there are two pieces motor, to drive this gearbox. So they are in series, so the voltage will be 2 times 7 volt or something, 13 to 14 voltage DC voltage. And this big motor I also use 14 DC volt to drive it. And actually inside this plastic cases, underneath the main board there is another board. Inside is the relay board. I bought it very cheap, this something like this, 4-piece relays. Underneath here is relay board here, totally two boards. This is self-made, and here is 2 more relays, and you can see there are 5-piece MOSFET. Actually, you can say why this? Just use relays to turn on it or to reverse the motor directions, but actually it's not such simple. So later on I will explain. This two is the 5 volt regulator, and under I take off this tape. You can see here, they are hidden by the wire. Under the wire is some optocouplers. There is 2-piece optocouplers to handle the signals before letting the signal directly to the MOSFET for insulation purpose. better. So that's actually that's all the functions of it. And this socket, 15 pins, will be output connect with here. Will connect to the machine's brains or machine's the missile card, and there are some socket here as well. So that's all for it. And why I need to use the MOSFETs? Because in driving the big motor or this two medium-sized motor, I need to change the speed or the power. This speed is also in terms of power, so I need to have this and to have different gate voltage on this MOSFET. This MOSFET is RF 540 to have different output current or voltage. So just have this adjustment, and this is 5. And let me explain the software. This is the 3D model, and I use for engineering. And for the electronic, here I do the circuitry and the PCB layout here. You see this one. This one actually is here. This board, and this is the whole pieces. And then I divide this into six pieces. Yes. And I use the design spark. Right here. Actually here, design spark PCB design. And another pieces is here. This is the main board here. And you can see both of them. There's the previous ones is two side board. Here is the bottom side. Here is top side. I need to connect the two sides through the VA holes by some little wet wire. And after doing this in this software, I need to machine the PC board here. I use the fat cam. It's quite useful and handy software. And I machine this on the CNC machine with some small green cutter. And for this plastic board, plastic board, I 3D print it out, and after doing the 3D model, I put it on here this software Cura, and put it on my machine. And this material is high impact polystyrene HIPS. It's quite a good material, easily be painted, and no much warp gauge or deformation. And almost that's all for now. Here is quite messy. And for the software, I need to, for the toolchangers programs, I need to do it on linear CNC, an individual program. I already done it, or not fully, but just I think 17%. And I try it. You can see this on this board, and you can see here. Let me take it off. The meat circle is underneath this board. This is the expansion for the expansion port. This is a breakout board. Yes, this is the breakout board for the two expansion port of the Mesa 76 something EI. I don't remember actually. And in this panel, I prepare this hard key for the toolchangers, for the 7 toolchangers, and also LED here. But the circuitry inside here not yet connect. Actually, I can use the on screen by touch screen. I don't do this. I think his hard key is much better. And that's all for now for this episode. And thank you for your watching. If you like it, please thumb up.